In an electrical system, a fuse is a safety device designed to protect the circuit from excessive current. Its function is to interrupt the flow of electricity when the current flowing through the circuit exceeds a predetermined threshold. This helps prevent overheating and potential damage to the circuit components, as well as reducing the risk of electrical fires or other hazards. Fuses are typically made of a metal wire or strip that melts when the current exceeds the rated value, breaking the circuit and stopping the flow of electricity. They are commonly used in household electrical systems, automotive circuits, and industrial applications to provide reliable overcurrent protection.
A relay is an electromechanical device used to control the flow of electricity in a circuit. It consists of a coil of wire wrapped around an iron core, known as the electromagnet, which generates a magnetic field when current flows through it. This magnetic field then attracts or repels a movable armature connected to one or more electrical contacts. The relay has two main states: normally open (NO) and normally closed (NC). In the normally open state, the electrical contacts are separated, and no current flows through the relay. In the normally closed state, the contacts are in contact with each other, allowing current to flow through the relay. Relays are commonly used to control high-power or high-voltage circuits using low-power signals. They provide isolation between the control circuit and the load circuit, protecting sensitive components from damage. Relays are widely used in various applications such as automation, automotive, industrial control, and telecommunications. They offer advantages such as reliability, long lifespan, and compatibility with different voltage and current ratings. Connecting a DP/DT switch directly to a motor and a resistor potentiometer in series can achieve motor direction reversal without the use of a relay. Here's how you can do it. 1. Motor connections. Connect one end of the motor to the common COM terminal of the DP/DT switch. 2. Power supply. Connect the positive plus terminal of the power supply to one of the center terminals of the DP/DT switch, and the negative terminal to the other center terminal. 3. Resistor potentiometer. Connect the resistor potentiometer between the other end of the motor and the negative terminal of the power supply. 4. DP/DT switch. The DP/DT switch has 6 terminals, 2 commons COM, and 2 pairs of normally open NO and normally closed NC contacts. Wire one pair of NO and NC contacts to reverse the polarity of the power supply to the motor. Wire the other pair of NO and NC contacts to control the speed of the motor by adjusting the resistance with the potentiometer. 5. Motor direction control. By toggling the DP/DT switch, you can reverse the direction of the motor. 6. Speed control. Adjusting the potentiometer will vary the resistance in the circuit, thus controlling the speed of the motor. This setup allows you to reverse the direction of the motor and control its speed using the DP/DT switch and the potentiometer without the need for a relay. However, please ensure that the switch and the potentiometer are rated for the current and voltage requirements of your motor to avoid overheating or damage. A parallel circuit is a type of electrical circuit where multiple components are connected in such a way that there are multiple paths for the current to flow. In a parallel circuit, each component is connected across the same voltage source, creating separate branches for the current to travel through. Key characteristics of a parallel circuit include: 1. Multiple paths. In a parallel circuit, the current has multiple paths to flow through. Each branch of the circuit contains its own set of components, such as resistors, lamps, or other loads connected in parallel with each other. 2. Constant voltage. All components in a parallel circuit are connected across the same voltage source. This means that each component in the circuit receives the full voltage of the source. 3. Independent operation. Unlike series circuits, where the current flowing through each component is the same, in a parallel circuit, the current flowing through each branch is determined by the resistance of that branch. Therefore, components in parallel operate independently of each other. 4. Voltage divider. Since each component in a parallel circuit is connected across the same voltage source, the voltage across each component is the same as the source voltage. This characteristic allows for voltage division, where the total voltage is divided among the components according to their individual resistances. 5. Total current calculation. The total current flowing into a parallel circuit is equal to the sum of the currents flowing through each branch. This is governed by Ohm's law, I equals V R, where the total current is equal to the total voltage divided by the total resistance of the circuit. Parallel circuits are commonly used in electrical wiring, household circuits, and electronic devices where it is necessary to power multiple loads independently. They offer advantages such as increased reliability. If one component fails, others continue to operate, easier troubleshooting, and the ability to add or remove components without affecting the operation of other components in the circuit. A transistor is a semiconductor device that is widely used in electronic circuits as a switch or an amplifier. It is composed of semiconductor material, usually silicon, with 3 layers: the emitter, the base, and the collector. There are 2 main types of transistors: bipolar junction transistors, BJTs, and field effect transistors, FETs. Here's a brief explanation of each type. 1. Bipolar junction transistor, BJT. A BJT has 3 layers of semiconductor material: the emitter, the base, and the collector. It operates by controlling the flow of current between the collector and the emitter using a small current at the base terminal. BJTs are commonly used as amplifiers in electronic circuits, where small changes in the base current can control much larger currents flowing between the collector and emitter. 2. Field effect transistor, FET. A FET has 3 terminals: the source, the gate, and the drain. It operates by controlling the flow of current between the source and drain terminals using an electric field applied to the gate terminal. FETs are commonly used as switches and amplifiers in electronic circuits, particularly in integrated circuits, ICs, and digital logic circuits. Transistors are fundamental building blocks of modern electronics and are used in a wide range of applications, including amplifiers, digital logic circuits, power regulators, oscillators, and radio frequency (RF) circuits. They offer advantages such as small size, low cost, low power consumption, and high reliability. Transistors have played a crucial role in the development of electronic technology and continue to be essential components in electronic devices and systems. Staircase wiring, also known as two-way lighting or two-way switching, is a method of electrical wiring commonly used in residential and commercial buildings to control lighting from 2 or more locations, typically at both ends of a staircase or hallway. This wiring arrangement allows for convenient control of lights from multiple switches, providing flexibility and convenience for users. In a staircase wiring system, There are typically two switches, referred to as two-way switches, controlling a single light fixture or group of fixtures. The switches are wired in such a way that the lights can be turned on or off from either switch, regardless of the position of the other switch. Here's how staircase wiring is implemented. 1. Two-way switches. Two-way switches have three terminals: common COM traveler T1 and traveler T2. These switches allow electricity to flow through the circuit in two different paths, depending on the position of the switch. 2. Wiring connections. The wiring connections for staircase wiring involve connecting the switches and the light fixtures in a specific configuration to achieve two-way control. The common terminal of each switch is connected to the line hot wire, while the two traveler terminals are connected to each other across the circuit. 3. Switch positions. When one switch is in the on position and the other switch is in the off position, the light is turned on. If the position of either switch is changed, the state of the light will change accordingly. This allows users to turn the light on or off from either switch location. Staircase wiring provides convenience and flexibility by allowing users to control lighting from multiple locations without the need for additional wiring or complicated circuitry. It is commonly used in stairwells, hallways, and rooms with multiple entry points. However, proper installation and wiring are essential to ensure the safety and functionality of the system. It's important to adhere to electrical codes and standards and to consult a qualified electrician for installation and maintenance.